Welcome to This Explainer. Today we're looking right past the standard data pipelines to explore the true art and science of analytics. We're going to break down exactly how the most successful data teams fuse human creativity with incredibly rigid, structured frameworks and advanced machine learning to drive massive enterprise value.
Here's our roadmap for today. First, the art of data. Second, the analytics framework. Third, categorizing and clustering. Fourth, detecting the anomalies. And finally, number 5, real-world business impact. Let's jump right in.
Section 1. The Art of Data.
Now, human creativity is actually the ultimate driver of data value. Think about it. Raw data? Well, it's really just noise until an analyst connects the dots. The true art here lies in translating all those complex data sets into a compelling, urgent narrative. You need a story that literally forces leadership to take decisive action. Honestly, anyone can run a SQL query or spin up a dashboard, but it takes a highly creative mind to look at a statistical output and truly understand the underlying human behaviors driving those numbers. The magic happens the moment you stop looking at data as just a historical record and start using it as a forward-looking compass.
So why does this creative mindset actually win in the marketplace? Well, there are 3 big reasons. First up, uncovering hidden insights. A creative analyst doesn't just stare at internal sales figures, right? They pull in external variables. By analyzing how something like regional weather patterns impacts consumer demand, they can optimize pricing or tweak the supply chain to prevent stockouts. That is a massive competitive advantage that a standard run-of-the-mill report would completely miss. Second, solving complex problems. When a business hits a wall, like, say, an unprecedented spike in customer churn, a creative analyst sees an opportunity. They dig into the behavior to figure out exactly when and why users are leaving, turning that major risk into a blueprint for a brand new loyalty program. And finally, communicating effectively. Listen, you can build the most sophisticated predictive model on the planet, but if you can't bridge the gap between that complex math and the overarching business strategy, the model is basically useless. Highlighting the so what is absolutely crucial to ensure the data actually dictates the strategy.
Moving on to Section 2. The Analytics Framework.
Okay, so this continuous improvement cycle is essentially a complete mental map of how execution happens at an enterprise scale. It goes to show that modern analytics isn't just about aimless data mining or blindly hunting for patterns without a goal. It's a highly disciplined, cyclical strategy. We have to ensure our creative thinking is permanently tethered to actual business objectives. Without a rigid framework like this, organizations risk getting totally lost in data swamps, spending millions of dollars on infrastructure without seeing any actionable returns.
By following these 5 chronological steps, a business guarantees that every single terabyte of data serves a core priority. Step 1, set a vision and solidify foundations. This usually means tackling massive hurdles like data governance, privacy compliance, and system architecture. Step 2 forces alignment with the C-suite to prioritize high-value business opportunities. In Step 3, we pick the best analytics approach. We're meticulously choosing the exact algorithm or model that fits the specific problem. Step 4 is securing the data and extracting insights. This requires intense data cleaning, which, fun fact, is often where data scientists spend the vast majority of their time. And crucially, Step 5 is defining and executing the response. Again, a model does us no good if business operations don't actually adapt to what it finds. We act on the insight, measure the impact, and loop right back to the beginning to keep improving.
All right, Section 3. Categorizing and Clustering.
Let's look at 2 heavy hitters in our machine learning toolkit. First, classification. This is a supervised learning technique. Imagine we use a massive training dataset with known historical labels to teach the machine. We feed it thousands of emails explicitly labeled spam and thousands labeled not spam. The model learns the features of both, so going forward, it can autonomously categorize new emails. On the flip side, we have clustering. This one is an unsupervised approach, and it's an absolute game changer for discovery. We basically feed the machine a massive, chaotic pile of unlabeled data and tell it, hey, go find some hidden structures on your own. For example, it might organize millions of customers into distinct purchasing groups based on complex behaviors without us ever defining those segments in advance. This is exactly how marketing teams uncover highly profitable demographics they never even thought to target before.
Which brings us to Section 4, detecting the anomalies.
So clustering is all about finding the norm. Anomaly detection actively hunts for the outliers. Think of it as our ultimate early warning system. We are desperately looking for those unusual needles in the data haystack. Because at the enterprise level, when data heavily deviates from the expected pattern, it's rarely just a harmless glitch. These anomalies are usually the very first warning signs of coordinated fraud, a catastrophic system failure that's about to happen, or a massive shift in consumer behavior that could literally make or break a fiscal quarter.
Let's break down the three main types of anomalies because they manifest very differently. First, a point anomaly. This is just a single data point that is wildly out of bounds. Imagine a sensor reading 50 degrees Celsius inside a commercial meat freezer. That's a localized failure that threatens immediate ruin for a supply chain. Second, we have contextual anomalies. Here, the data point itself might seem normal, but its environment makes it super suspicious. For example, a $5,000 credit card charge at a luxury hotel is perfectly normal for a CEO on a business trip, but it's a glaring anomaly if that same card is normally only used for $20 gas station purchases in Ohio. Finally, collective anomalies. This happens when an entire sequence of data points forms a weird pattern even if the individual points seem okay on their own. Like a massive sudden surge in global website traffic hitting a specific server followed immediately by a sharp drop. That is the classic textbook signature of a coordinated bot attack or a DDoS attempt.
Now, when we're training models to catch these outliers, we have to weigh our approach carefully. Supervised learning is incredibly accurate because it learns from a rich history of correctly labeled examples, like thousands of confirmed past fraud cases. The catch? Procuring and manually labeling all that data is wildly expensive and time-consuming. Unsupervised learning, however, is fantastic because it requires zero labeling. It just analyzes the data, figures out the baseline normal, and flags anything that breaks the mold. This is perfect for catching brand new types of fraud no one has ever seen. But the huge downside here is false positives. It might flag a perfectly valid brand new customer trend as a dangerous error. And in business, false positives cost money, like automatically locking a legitimate, high net worth customer out of their bank account just because they bought coffee in a new city.
Let's bring it all home with Section 5, Real-World Business Impact. We've covered the creative mindset, the structural frameworks, and the foundational algorithms. Now, let's look at how all these elements fuse together to solve really high-stakes, multi-million-dollar problems across totally different industries. This is where the theory actually translates into measurable enterprise value. Scenario 1. Imagine a global streaming giant that is just hemorrhaging subscribers, a metric we call churn. This is an existential threat to their recurring revenue. But by feeding viewing habits, login frequency, billing history, and demographics into advanced predictive algorithms, like decision trees, analysts can predict a cancellation before the user even clicks the button. By spotting the behavioral triggers, maybe a big drop in watch time right after an interface update, the system can instantly deploy targeted retention offers, saving the user and protecting that revenue stream.
Scenario 2. Let's pivot over to cybersecurity. For a major e-commerce platform, stopping bad actors is quite literally a millisecond-by-millisecond battle. By deploying anomaly detection frameworks, specifically using algorithms like isolation forests, the platform doesn't just look at the final checkout price. Instead, it aggressively analyzes real-time IP routing, keystroke typing speeds, device fingerprinting, and micro-purchasing behaviors. This allows them to freeze fraudulent transactions while they are happening, shielding the business from massive chargeback liabilities.
Scenario 3. Consider a global manufacturing firm absolutely crippled by recurring production bottlenecks. Time series forecasting doesn't just guess the future to solve this, it ingests geopolitical, supply chain data, historical weather patterns affecting shipping lanes, and raw material availability to predict exact market demand months in advance. Armed with that foresight, the manufacturer can reroute shipments, tweak factory output, and optimize inventory reserves. We're talking about data actively eliminating millions in wasted operational costs and totally revolutionizing their efficiency.
As we wrap up this explainer, I really want to leave you with this thought. Data analytics is not just a technical function, it's the ultimate strategic art form of the modern enterprise. It's the bridge between raw numbers and human action, turning invisible behavioral patterns into undeniable competitive advantages. So I challenge you, what hidden story is your own data currently trying to tell you? And more importantly, do you actually have the right framework in place to listen to it? Keep analyzing, keep innovating, and we'll see you next time.